Let's solve February-March 2026 paper 4-2. Question number 1. You can see what they're asking. The first part is state the distance between home and school. So the total distance between home and school is 1.7 kilometers. And these are the sections where you can see some movement, distance is covered, and that is the flat line which shows the time only. So we excluding this part. Okay, that is the total distance covered. State one point ABCD, which identifies a time when the student accelerates and the student decelerates. So the student is accelerating where the graph is actually showing you the steepest part. The steepest part of the graph is showing you the acceleration, and this part from B towards C, that is the part which is actually showing you the steepest part, and that represents the acceleration, while the less steep part of the graph is showing you the deceleration. And you can see over here from C onwards towards D, you are having the less steep part, and that is showing you the deceleration. So C is showing you the deceleration and B is representing the acceleration. Okay. Part C, use figure 1.1 to calculate the student's maximum speed. For maximum speed, you can calculate the gradient of the graph. You can use this formula, change in distance over time or change in time. So for this, we are about to calculate this part, which is the steepest one. So from the steepest part of the graph, we are calculating the maximum speed, because this is actually representing the acceleration. And from, okay, these are the points from where we can take the time difference, which is 2.5, and the total distance covered is from 0.4 to 1.5 is how much. You can see over here 1.5 minus 0.4 and divided by 7.5 minus 5, you would get 0.85 over 2.5, and that is the total distance and the time taken. You would get 20.4, and you can round it off to one significant figure. Either you can write it in three significant, this is up to you, but it depends upon the raw values given in the question. The raw values are the values which is given in the question data. So whatever the number of significant figures used in the question data, you must be writing your answer to that much number of significant figures. The unit used over here is kilometer per hour, so that's why we have not converted kilometers to meters or hours to seconds. Question number 2, state the equation that links density, mass, and volume. And you can see the equation over here. Density is equals to mass over volume. Now, the next question is calculate the volume of the steel cube. So the volume, we can rearrange this formula for volume, which is V is equals to mass over density. And the mass is given. The mass is 110, and the density for the steel is given, which is 7900, and this is equals to 0.014 meter cube. The density of the seawater is 1030 kg per meter cube, and state why the steel cube sinks when placed in seawater. So the density of the steel, solid steel, is 79, which is greater than the density of the seawater. So that's why it will sink. Explain why the steel ship in figure 2.1 floats on the seawater. The ship is not solid steel. It is not all made up of solid steel. It contains a large volume of air as well. So that's why, which makes it, which makes its average density less than the average density of the seawater. So the overall density of the seawater is greater than the overall the average density of the ship. That's why it is floating on the surface of seawater. The mass of the ship is 3.5 times 10 to the power 7 kg, and the ship accelerates 0.7 meter per second square. Calculate the force which causes the acceleration. So we know the formula for calculating the resultant force, which is ma, and we are multiplying mass with acceleration, and you would get the answer by plugging in the values in the calculator. Explain why the force provided by the ship engine must be larger than the value in 2b1. So this is an ideal case where we are ignoring the drag force. So in actual, the drag force must be there. So because the engine must overcome the drag force in addition to provide the force for acceleration. So force for acceleration given is 2.6 times 10 to the power 7, but actually in real what happens, the ship must be overcoming the drag force, the water resistance as well. Okay, and maybe there is a resistance, but we can write the drag force. So that actually tells the examiner that this drag force is actually resisting the motion, and the engine has to overcome that resistance first, and then it is going to accelerate the ship. The force is accelerating the ship. Question number 3. You can see a polar bear is given and a person is standing upon thick ice, both of them. The polar bear mass is given and the area in contact is given, and the person mass and the area in contact is given. Now they're asking for calculate the weight of the polar bear. So the weight of the polar bear can be calculated by using this equation. W is equals to mg, and you already know this formula. So we are multiplying the mass of polar bear because we are calculating the weight of polar bear. So keep this thing in mind. You must not use this mass of person because they're asking for the weight of the polar bear. Most of the time, because of the careless reading, we are missing the point. So be very careful with the question. Read each and every word and all the statements given in the question very carefully. Writing answer is not difficult, but understanding the question is very much important. So the total weight of the polar bear is 5800 Newton. Calculate the pressure that the polar bear exerts on the ice. How much pressure it's exerting? So obviously the pressure formula is force per unit area, and this force exerted by the polar bear on the ice is the weight of the polar bear. So that is the actual value. The one I used here is the rounded value, which is rounded to two significant figures, but the actual value was this one. So you can write the rounded value or the actual value, it doesn't matter, because at the end you are going to round off your answer. So 5782 divided by 1.12, and we are getting 5162.5, and if we are rounding that off to two significant figures, we must be using the same unit. Yeah, and the answer we are getting, the rounded answer into significant, is 5200. Part 3, use the numbers to complete each equation. The mass of polar bear is equals to how much times the mass of the person. So if you multiply out of these numbers, if you multiply the 7 with the mass of the person, you would get the this mass equals to the mass of the polar bear. Now area of the polar bear in contact. So how much times to the person's area of contact? So polar bear area of contact is 56 times the person's area in contact. Okay, pressure exerted by person. How much pressure the person is exerting is, that pressure is equal to force per unit area, and the area, if the area is smaller, the pressure is greater. So obviously the person standing on the ice is, the area of the person standing on the ice is smaller, are very, very, very much smaller than the polar bear's area in contact. So that's why the person is exerting more pressure, and the pressure exerted by the person is 8 times to the pressure exerted by the polar bear. Under the ice, in seawater with a density this much, calculate the change in pressure. So the change in pressure, or the liquid pressure, can be calculated as density times gravity times height, rho gh. And if we are plugging in the values in this equation, the density is given, g value is 9.8 and the height is 2.5. You will get 2.55 into 10 to the power 4 pascals. Question number 4. You can see the people are sitting close to the heater. State the method thermal energy transferred that warms the people. So how this energy, thermal energy, the heat energy, is transferred to the people sitting close to the heater. So this heater is actually emitting or radiating, okay, are emitting radiations, and these radiations are infrared radiations. So the energy is actually transferred to the people through uh, infrared radiations. Although if you don't know the exact radiation, like which type of radiation are those emitted by the heater, so you can just write radiation. Okay, you can only write this infrared radiation if you know, but most of the time, whenever an object which is transferring heat So the heat is transmitted most of the time through infrared radiation from most of the electrical appliances. Okay, complete the sentence. The heater transfers energy to the thermal store of the table, and the temperature of the table increases. So, if the temperature is increasing, it means that the energy absorbed by the table is more than the energy emitted by the table. Okay, so there is no such thing like thermal equilibrium. Thermal equilibrium is when the energy absorbed is equals to the energy emitted, then the temperature remains constant. But here, the table temperature increases, that's why the energy absorbed is more than the energy emitted by the table. Now, uh, also keep this thing in mind. I wrote a point over here. Most of the time the students do this mistake because they know that black is a good absorber, but they don't know black is a good emitter as well. So black is good in emission and absorption both. So black is a good absorber and emitter, and white is a poor absorber and poor emitter. One of the people puts a white cloth over the table. Explain why the white cloth causes the temperature of the table to decrease. Now, why it is doing so? Because white is a poor absorber of heat or a good reflector of heat. So in reflection, white is better than any dark color like black. So the table will absorb less thermal energy, and that's why its temperature will be less. The heater has a power of 2.5 kilowatt, and it remains on for 3 hours. Calculate the energy in kilowatt hour. This kilowatt hour is the unit of energy transferred electrically by the heater. So energy is actually power multiplied by time, and you know the SI unit is watt second, or you can write it, okay, joules. This watt second is equals to joules. But right now, as they were asking in the question, the unit should be kilowatt hour, so we must keep the same units. We are not changing the R and kilowatt. We are not converting it to other units. Okay, so here we are using 2.5 and 3 hours, and we will get 7.5 kilowatt hour. Question number 5. Okay, in this question we will be using the Boyle's law. Atmospheric pressure is given. The volume of air at atmospheric pressure is also given, and the pressure in tire is given, which is 2.6, but the volume of air inside the tire is not given, so we must be calculating this V2. I mentioned this is P1, V1, this is P2, but V2 is missing, so we should rearrange this equation for V2, which is P1 V1 over P2. Okay, and you know the values, you can just plug in the values. P1 is here, okay, so we write it here, and then this is V1, and this value is given over here, 2.6, and you would get 0.39 meter cube. Describe the structure of the gas in terms of separation, arrangement, and motion of the particles. Okay, so be very careful with these terms, arrangement, separation, and motion of the particles. So separation, if we compare solid, liquid, and gas, so the gas particles are further apart. Okay, they are away from each other. Now the arrangement of the gas particles they are randomly arranged. And if we talk about the motion of the particles, so they are having the highest kinetic energy, uh, and they must be having the greater speed as well, and also they are randomly arranged. So they are randomly arranged, you can write it even here in the arrangement section. Sorry for this, they are randomly arranged, we know this, and they are having a higher speed because they are having a greater kinetic energy. Explain in terms of particles why the internal energy of the gas decreases. So the answer is, at lower temperature the kinetic energy of the particle is low, since internal energy is the sum of kinetic and potential. So if internal energy IE is equals to KE plus PE, if PE, the potential energy, is even constant and the kinetic energy decreases, so the overall internal energy would decrease because internal energy is depending upon both kinetic and potential. Question number 6, a diagram is given and they're asking identify Z. This Z is actually showing you or representing the principal axis. Determine the focal length. Okay, so how should we get the focal length? By drawing this ray diagram, one ray parallel to the principal axis is hitting the lens, and once it hits the lens, it always refracts and passes through the principal focus. And another thing is, once those rays are refracted, by the way, this line which is passing through the center of the lens is showing no refraction at all. Okay, so it is passing straight, but this one is showing you the refraction, and where they are meeting here. So we must be looking that point, for that point where the this ray is passing through the principal axis. So the point on principal axis where this ray is passing through is the point which we call the principal focus. So beta, you have to draw these two rays, and from this ray we would get the principal for focus. Now, what should be the focal length? Oh, we don't really know the exact focal length because I'm using the soft copy. In hard copy you would get more accurate, focal length. But right now I can just write the range. It must be between 2 centimeter and 2.5 centimeter because I'm using this soft copy. Image in figure 6.1 is inverted. State two other characteristics of the image. So the image is real and the image is having same size as the object. Now they can ask, the examiner can ask you a third question as well, where the object is placed. So whenever we are getting the same size image, or if the image of the size of the image is the same as the object, then it must be placed upon double focus. And if the object is placed upon double focus, then the image we will be getting is also would be upon double focus on the other side. Now the lens in 6.2 used a magnifying glass. So whenever it is used as a magnifying glass, it will be producing a virtual image. Now draw an X on figure 6.2 or cross on 6.2 show the position of the object. So if the lens is producing what it is producing a virtual image, let's say, so this object should be placed in between the center of the lens and the focus point. So if you're placing this object anywhere between those 2 points, you would get a virtual image, and the lens would be uh, used as a magnifying glass or acting as a magnifying glass. Now put a tick alongside the two statements which describe the position of the magnified image. So where is the magnified image? On the same side of the lens as object. You can see over here this cross. If the object is placed here, then this ray is passing through the focus point and the other one through the center, and they are not meeting anywhere on this side, on the opposite side. So it means that if we are drawing these rays and they are not meeting here, so they must be meeting. If you are tracing these rays back, you must get a point where they are meeting, and that is the point where the image is produced. This is an upright, virtual, and magnified image. Okay, and further away from the lens than the object, obviously the image is further away as compared to object, because object is placed very close to the lens. Question number 7 shows two identical cells in series, thermistor and fixed resistor. Determine the EMF of one cell. Give the unit. So okay, the cell, if the total voltage or the voltmeter value is 9 volt, it means that this voltmeter is showing you the total potential difference or the total voltage drop across both these components. So this total potential difference must be equals to the EMF. If the total EMF is 9 volt, then each cell is having 4.5 and 4.5 volts. So EMF of one cell is how much? 4.5 volts. Complete the sentences to define the electric current. Electric current is the amount of charge passing a point per unit time, and that is the equation, charge per unit time. A resistance of a fixed resistor is 480 ohm. Calculate the resistance of the thermistor. So you must be calculating the total resistance first, and then you are subtracting this 480 and you will get the resistance for the thermistor, because only two components are used. One is fixed resistor and the other one is thermistor. So if you calculate the total resistance can be calculated by this equation, V is equals to IR. And if we rearrange this equation for R, then we would get R is equals to V by I. And this voltage is the total voltage, and this is the total current. The ammeter is showing you the total current and the voltmeter is showing you the total voltage. So how much is the current over here 4.6 milliamps. So this is a prefix used over here, 10 raised to power minus 3, to convert this current to amperes from milliamperes. And the total voltage is 9 volts, and you would get the total resistance, which is 1956.5. And if you subtract the resistance of the fixed resistor, then the leftover resistance would be equal to the resistance of the thermistor, which is 1500 ohm. I wrote some prefixes over here. You can just go through it. The thermistor is placed in a beaker of ice. Now what is happening, they're saying that the thermistor temperature is decreasing. So if the temperature of the thermistor, this is the thermistor, let's say, and if its temperature is decreasing, then what happens? The resistance is increasing, because temperature and resistance has inverse relation. So if the resistance is increasing, it means that the current across the thermistor is decreasing, because current and resistance has inverse relation. Resistance increases, current decreases. So what happens? But what about the total voltage? Like the voltmeter is still showing you the total voltage. The total voltage would not change. It will still be 9 volts. Although if the value of voltage, because voltage and resistance are proportional, if the resistance is increasing, then the voltage across the resistor is increasing. So it means that it will be taking, a greater part of voltage, like there would be more voltage drop across the thermistor, but still some of the voltage would be taken by this resistor as well. Like initially they were getting 4.5 and 4.5 volts, but right now, if suppose its resistance is doubled, so it means that it will be taking more voltage. Let's say it is taking 6 volts and it is taking 3 volts. So the voltage, the sum of those two is still 9 volts. And if they are getting 4.5 and 4.5, so it means that the voltage is still 9 volts. So it cannot increase that value. Okay, the total voltage across both the components, the voltage drop across both the components would be equals to 9 volts, the total voltage. Okay, so that's why we are writing the voltmeter reading remains the same, but the reading of the ammeter decreases. Why? Because the current decreases. Now next, calculate the input voltage in the step-down transformer. If some values for the transformer turns are given, like that is representing the primary turns, this 43 is the secondary, and the output voltage is 230. The output voltage is over here across the secondary coil, and the primary voltage is missing across the primary coil. We have to calculate it. So if we rearrange this formula for VP, like the primary voltage, then we would get this VP is equals to 230 times 6 is to 200 divided by 43, and you would get this input voltage, which is 33,000 volts. So power of the kettle is given, secondary coil of the transformer, calculate the current in the primary. Okay, so we are calculating the current in the primary coil when the transformer is 100% efficient. So first of all, we need to calculate the total current. Total current can be calculated using the formula of power, which is voltage times current, and I is equals to P over V if we are calculating the total current. So the total current can be calculated by using these values, P over V, and P is how much? That is 2.2 into 10 to the power 3 watts, because it was given in kilowatts. So this 10 to the power 3 is the prefix for kilo. Okay, that is kilo in 10 raised to power 10 raised to the power. We are dividing that by 230, and you will get the total current 9.56. Now that is the total current across the secondary side. So for the primary side, if you rearrange this, okay, this tells you that input power is equals to the output power for 100% efficient transformer. And if you're rearranging this equation, so Vs times Is over Vp, that is equals to 239.56 and 33,000, you would get the value for current 0.067 amperes. Now a power station produces 1.3 gigawatts of electricity. 1.3 times 10 to the power 9 watts. Giga stands for 10 raised to the power 9. Now a transformer at the power station steps up the voltage. Therefore, before the electricity is transmitted, this reduces the power loss during transmission. State the equation for power loss, that is P is equals to I square R. A very important question. Explain how the step-up transformer reduces the power loss during the electricity transmission. So I wrote the explanation over here. By stepping up the voltage, reduces the current. So the total power remains constant during this transmission. So if the voltage is increasing, the current is decreasing. If the current is decreasing, the voltage is decreasing. Okay, so they are increasing or decreasing with the same ratio. So that's why if you are stepping up or stepping down, the total power remains constant on both the sides. For the same power, okay, the by stepping up the voltage reduces the current for the same power. Okay, so the power is constant, that's why I wrote same power. Since the power loss is P is equals to I square R, so a lower current significantly reduces heat loss. It means that the value of current is I squared. So this lower value of current reduces the heat loss. Okay, because if the current is very high, the electrons must be flowing with a high speed and they would be colliding more and more heat would be produced in transmission cables. Next question is about alpha, beta, and gamma. Nuclear physics. Alpha, beta entering an electric fields between two charged metal plates P and Q. That is P positive and Q is negative. Now draw the path of alpha and gamma. So alpha is deflecting towards the negative because alpha is positively charged, and gamma has no charge, so it will pass straight without showing any deflection. Okay. A student places, now they're asking in the next question that a student is placing a paper over here. Before this beam reaches the electric field, a paper is placed in front. So what happens? The alpha is having a very low penetration power, but gammas are having the greatest penetration power. So it can be absorbed by the paper or it will stop here, the alpha particles. It cannot penetrate through the paper and passes and enters into the electric field, so it will be stopped. The alpha will be stopped here. But when it comes to gamma passes straight and it will pass through the paper, because the paper cannot stop the gamma radiations because they are having the greatest penetration power. So alpha will be stopped by the paper and gamma will remain undeviated or undeflected, unaffected. It will go straight. A beam of alpha and gamma is replaced by beta. State and explain path of the beta particles. So beta particles are very smaller as compared to alpha. Alpha's mass is very much greater than beta. So if beta particles are smaller, it means that they would be deflecting towards the negative plate with a sharper curve. Okay, so beta will be deflected towards the positive plate with sharper curve than alpha. Alpha is having greater mass than beta, so that's why they are taking time. And when it comes to beta, so beta is deflecting towards positive with a sharp curve, and as beta particles are negatively charged, so it will be attracted towards the positive. Opposite charges attract. Okay, so that's what they are asking in this question. Explain the path of beta. Use ideas about electrostatic force. Electrostatic force is the force between positive and negative charge. So that's why I wrote it here. Towards the positive plate and have much smaller mass. That's why they deflect more. Question number 10. Planetary nebula is a part of life cycle of a star. Complete the sentence about the planetary nebula. Stars expand when they run out of hydrogen fuel nuclear reaction to fuel nuclear reaction. A dish forms a planetary nebula. So a red giant is forming a planetary nebula. Okay. State what is the center of the planetary nebula. It is white dwarf. Center of planetary nebula is having a white dwarf at its center. The next question is two wavelengths are given. One is for red and the other one is for blue. Blue is having a smaller wavelength according to this mnemonic we are using, WebCure. Violet, indigo, blue is having the smallest wavelength, and as we are moving towards red, the wavelength is increasing. So explain why the light in with a wavelength of 5 times 10 raised to power minus 7 is the blue light, because blue light has shorter wavelength than red light. Speed of light in vacuum is this much. Calculate the frequency. So frequency is equals to V by lambda, or V is equals to F lambda, and you can rearrange this for frequency, which is equals to V by lambda. And plug in the values. Speed is given, the wavelength of blue light is given, and you would get the frequency for the blue light, which is 6.0 into 10 to the power 14 hertz. Question number 11. This equation is given and they're asking define the terms r and t. So r is the average radius of the orbit and t is the orbital time period. The average orbital speed of the Saturn is 9600. Explain why the orbital speed is an average value. So why we are saying that the orbital speed is an average value. A planet orbit is an elliptical shape. Okay, the all the orbits are revolving around the sun in an elliptical shape orbit, not uh, perfectly circular. Okay, so the path of the planet is not a perfect circle, but it is elliptical, where they okay where they are not at the center of orbit. Therefore, average value of the orbit circumference and time period are used. Part 2, Saturn 1.4 times 10 to the power 12 meter from the sun. Show that one Saturn year is approximately equal to 30 Earth years. So we must be calculating the time period. So how to calculate? Let's rearrange this formula for time period, which is 2 pi r over v. And if you plug in the values, the radius is given, and that is the speed of Saturn, 9600, and you would get the total time. Now the total time it get is 9.2 into 10 to the power 8 seconds. So if we divide this total time by a number of seconds in 1 year, which is 365 to 24 hours and 3600 seconds, so the total amount of time you are getting in 1 year, or you are converting 1 year time period into seconds, so you can write it this way. We are dividing the total time we have calculated here by this 1 year time, then you would get 29.404, and that is approximately equals to 30 years. That's the end. Thank you so much.